Okay, so let's now calculate the PMF of a sum of two geometric random variables. So let's say that x1 is geometric with parameter p, x2 is geometric with parameter q, and they are independent. So then what we want to check is the PMF of y, which is the sum of x1 and x2. So we start with p of y equals to y. This is to be found. So then we apply the definition, x1 plus x2 equal y. Then we say we fix one of them, and x2 equals to y minus x1. And then we sum from x1 is equal to 1 to y minus 1. Because a geometric random variable cannot go below 1. Okay, so x1 is equal to 1. We'll make sure that the minimum value of x1 is 1, and x1 is equal to y minus 1. We'll make sure that the minimum value of x2 is equal to 1. So then we apply the independence property. P of x1 equals to x1, P of x2 equal to y minus x1. Now we apply the actual PMF of geometric random variable, which is equal to 1 minus p to the x1 minus 1 times p, then 1 minus q y minus x1 minus 1 times q. This is equal to pq. So then there's another thing we can take away, which is minus 1 here, and we can take y minus 1 here out, and then times x is equal to 1 to y minus 1, 1 minus p over 1 minus q to the power of x1. So this is the PMF of the sum of two geometric random variables with different parameters p and q respectively. Now a specific case of interest is when p and q are equal. In that case we have probability of y equals to y. This is equal to p squared 1 minus p y minus 2, and then these values are all 1, so we are just summing 1 y minus 1 times, so times y minus 1. So this is the PMF of y when both of the geometric random variables are geometric with parameter p. Okay, now note that if any x, for example, if x is geometric with p, then x1 minus 1 is not geometric, is a negative binomial with parameters 1 and p. Okay, why can we say that? We can say that because a geometric random variable defines the number of trials until the first success, and a negative binomial variable with parameter 1 defines the number of failures before the first success. So naturally the number of failures will be 1 less than the number of total trials for the first success. So similarly we can say x2 is also, if this is the case, then and x2 minus 1 is also negative binomial for the same reason. Now let us define z is equal to x1 minus 1 plus x2 minus 1. So which is equal to x1 plus x2 minus 2, which is equal to y minus 2. Okay, so now we come back to our PMF of y, so which was p2 1 minus p y minus 2 times y minus 1. Okay, now this I can write in terms of z, so I can say p2 1 minus p to the z times z plus 1. This I can write it as p2 1 minus p z, then z plus 2 minus 1, choose 2 minus 1. Okay, so now let's compare this with the PMF of a negative binomial. Negative binomial, we have p to the r 1 minus p to the x plus r minus 1, choose r minus 1. So then this means that z is actually, so this means that z is actually negative binomial with r is equal to 2 and parameter p. So what we actually proved here is that a sum of geometric random variable is actually a specified form of negative binomial random variable. If we see y, if we see the PMF of y, this is not exactly a negative binomial, but if we just transform it y, but just by translating it by subtracting 2 from it, then we actually see that this is actually a negative binomial random variable. What does it mean in practice? In practice it means that y is actually the number of trials which include the 2 successes, and z is actually the number of failures until we find the second success. So there is a relationship between a geometric random variable and a negative binomial random variable, and consequently there is a relationship between a sum of 2 geometric random variables and a negative binomial random variable with parameter r is equal to